We're going to look at an example with multiple substitutions and how that works, doing more than one substitution. So you see we've got this big old complicated function. There's lots going on. But remember, the first step is just to look for where is there something that's nested that I might be able to work with. And so in this case, I see that I've got this 3x squared plus 5 as a nested function. And I actually see that it shows up twice. So anytime you see something like this where it shows up multiple times, it's a pretty good candidate for what you want to substitute. So I'm going to call this my u. And that means my du, let's write these up nice and clean. So I'm going to erase that so I can record everything in the corner here for later reference. So u equals 3x squared plus 5 du by dx equals 6x plus 0, which means that dx equals du over 6x. So let's plug that in. We get the integral of 18x sine of u squared cosine of u du over 6x. The 6x and the 18x will cancel or reduce and leave me with the integral of 3 times sine of x squared, sine of u squared times cosine of u du. And you'll know that you've done an okay or a proper quote-unquote substitution because all of your variables will be the same. If I was left with an x, that would be a problem, but I've got u's and a du, so everything lines up nice and great. Now we don't know how to work with this. We haven't learned some like product rule or anything for integrals, but we do see another nested function here. Sine of u is inside the squared, so let's call that w. So come back up here, I'm going to say w equals sine of u. That means dw over du, because again, now we're working in terms of u. So I'm going to do dw over du, the derivative with respect to u. That's going to give me cosine of u, and that means that du should equal dw over cosine of u. Plug those in, and we get 3 times u squared, w squared, times cosine of u times dw over cosine of u. Cosine of u's cancel out, and we get the integral of 3w squared dw. And again, because these w's match, we know that we're, like what we've done is an okay substitution. It has simplified it. Looking at this, it's pretty straightforward. Just pull out the 3. We're left with w squared dw. And when you integrate that, we should get 3 times 1/3 w cubed plus c. And now we just go back, start plugging things in. So w, remember, was sine of u, so it's equivalent to sine of u cubed. And the 3 and the 1/3 cancel, which is why I didn't leave it there. Plus c. But remember, we have to also substitute u back in from above. So we have sine of 3x squared plus 5 to the 3rd plus c. And that is our result because we're back to x's like before. So that's an example of multiple substitutions or kind of more complex substitution. And this could technically repeat an infinite number of times. where you just keep substituting things in, and then when you get to the end, you just have to backtrack back all the way up through all of those substitutions.